Welcome, children. Calculate the instantaneous value at 60 degree, average value and RMS value of an alternating current whose peak value is 20 ampere. This is I theta graph and this is the alternating current. Good. It has a peak value equals plus or minus 20 ampere represented by Im. The path. The instantaneous value I equals Im sin omega t. What all the datas are given? Two datas are given. The maximum current and the theta value. 60 and 20 amperes are given. Then the first, we find the instantaneous value of the current, alternating current at theta equals 60 degrees. So I equal to Im sin omega t. Im is 20. We know that omega t is theta, which is equal to 60 degree. Sin 60 is root 3 by 2, right? 2 goes in 2010, then root 3 is 1.732, then multiplying that we get the instantaneous current small I equals 17.32 ampere. At pi by 3, we get the instantaneous value 17.32. Good. So let us go for the second part. The I average value of alternating current equals 2 Im by pi. Right, 2 divided by pi is 0.637 Im. You can use this formula directly and you can simply get your answer, the average current. Let us know how we get this formula. So this is very simple. Average value of current equals area of positive half cycle or area of negative half cycle, anyone you can take, divided by base length of the half cycle. So I average equals the area of the positive half cycle is given by integration 0 to pi I d theta divided by the half base length of the half cycle is pi. The instantaneous value I, okay, that meets the alternating curve within the angle d theta. This is the small area. The shaded portion is a small area. This has to be extended for the positive upper half cycle. That area is the average value. Good. So I average equals, once you integrate integration 0 to pi I d theta, you get 2 Im divided by pi. Here the small I is substituted as Im sin omega t. We have to proceed that mathematical part. Let us avoid this right now. So I average equals 0.637 Im. I average equals 0.637 multiplies 20. So we get I average equals 12.74 ampere. Let us go for the third part. The RMS value of current, alternating current equals Im divided by root 2. Let us know how we get this formula. So IRMS equals root of area of one full squared wave. Area of one cycle of squared wave divided by base length of one cycle. This is the squared current squared wave. And here we have I square value. We go and find the area under this I square value for an angle of d theta. So this area is extended for the full half cycle, right? Good. Now IRMS equals root of the area of one cycle of squared wave is given by integration 0 to 2 pi I square d theta. The base length of the one full cycle is 2 pi. We have to replace this I as Im sin omega t, then Im square sin square omega t, integration sin square omega t. You know that, okay, all these mathematical students, you know, and finally we get the answer IRMS equals root of Im square pi divided by 2 pi, which results in Im by root 2, which results in 0.707 into 20. So IRMS equals 14.14 ampere. Thank you, children.